Hi everybody. Today we shall be having a new topic, that is new regime of topic, that is called capacitance, and then we shall be studying about the capacitors, which covers a large area of electrostatics. So first we shall be talking about the theories, that is capacitance, what is capacitance, how it is generated, how it can be increased, and then to the topic of capacitors. Okay, so let's discuss about the capacitance. Capacitance. Okay, if we have a conductor, suppose a circular conductor, and I am giving it a charge q. If it is the radius r, then obviously all charges goes to its surface. It is either hollow or solid, does not matter, the whole charge goes to the outer surface of the conductor, whatever be the shape and size. If it is not circular, whatever, then its potential increases. And what will be the potential at its surface? That value is given by V is equal to 1 upon 4 pi epsilon naught q upon r. Q is the radius and r is the q is the charge given to the system and r is the radius. Okay, now see, if the radius of the conductor is not changed, it is fixed, then V, that is potential on the conductor or of the conductor, increases proportionally to the charge given to it. The more charge we give, the larger its potential increases by. Agree? According to this formula, that is, potential is directly proportional to the charge given to the system, or reversely we can write the Q is directly proportional to the potential. Its potential will increase the more charge you provide to the system. So this can be further written as Q is C into V, where C is a constant for the proportionality, and this C is numerically is equal to charge on the system to its potential, and this is called the capacitance. Okay, this C is equal to Q over V is known as the capacitance of that particular conductor. So this is the mathematics so far. What else can we understand in terms of capacitance is that capacitance is simply the ability of any conductor. This is simply the ability of any conductor to store the charge on it. Okay, it obviously every device, suppose you have a bottle of 1 liter, you cannot put more than 1 liter in that bottle because it has the capacity of 1 liter. If you take a bottle of larger size, you can put more water, obviously. So everything has its own capacity, and suppose I have 1 liter of bottle, however thick or however thin. If it is thin, it will be longer. If it is thicker, then it will be shorter. Agree? So for example, the common bottle that generally be used, it contains say of 1 liter of water. So when you start putting water, the level of water increases, and simultaneously the content that the water we have filled increases. The more it acquires its height, it means we are giving it more and more water. Height can be compared with the potential. Height can be compared with the potential. That is, height is say potential, and water can be compared with charge. The more water you provide to the bottle, the more it rises to a higher and then higher. Okay, this is how the in the similar or the same way, when you store or provide charges to any conductor, its potential increases, and after a certain time it stops storing further or more amount of charges because it has now got filled completely, and that time its potential becomes so large that you cannot give more and more charge to it. Okay, so and that at particular position, when its potential becomes enormously large, then it will not store any further amount of charge, and that time it is said that the capacity is now full, and we cannot give it to more quantity of charge. Okay, now come to this formula. So hopefully you got something bit of idea regarding the capacitor. It is the ability for any device to store amount of charge. So I am moving ahead. If V equals to 1, if V equals to 1, then capacitance C becomes equal to Q. So numerically what it means, the capacitance of any device is numerically equal to the charge given to the system to rise its potential by 1 unit. Okay, that is the charge required to raise its potential by 1 volt. Charge required to raise its potential by 1 volt is known will be numerically equal to its capacitance. Okay, this is the mathematical definition of your capacitance C. Suppose you have to give 1 coulomb of charge to raise its potential by 1 volt. It means what? Its capacitance will be equal to 1. For I have another conductor for the same rise of voltage, that is 1 volt, I am giving 5.5 coulomb of charges. Then what is the capacitance? Again its C will be 5.5. We shall discuss about the units afterwards. Let's come to this idea first. So whose capacity is more? Obviously this body or this device has more capacity, because its potential increases by 1 volt when we give it extra 1 coulomb of charge. In this case we give 5.5 coulomb of charges, then its potential increases by 1 volt. So it can be compared with, this is a device or bottle and this is another bottle or container. When you give 1 liter of water, its height increases by say 10 centimeter, and when this device is given 5.5 liter of water, then and then only its height increases by 10 centimeter. So now coming to this and this combination, if height is compared with potential, so this is the same gain in height but different quantity of water has been put. So when I put more quantity of water, its height rises by the same amount. So this container must have more capacity than this. Why? Because of its shape, its size. So capacitance of any device depends only on the size, not on the medium, not on the type of, we shall discuss afterwards. But first of all, its size and shape is very, very important. Okay, this is the idea of capacitance. So please go through your NCERT book very clearly, then and then you can get very easy ideas, because you cannot leave NCERT at any cost, for either for board exam or for JEE or for NEET or advance. So and at every cost, nook and corner, the NCERT has to be in hands. So this is about the capacity and this is the mathematical formulation. Now come to the idea of the principle of capacitance. What is the principle of capacitance? How it stores the charges. So let's discuss about that. Hope you might have got this, because little bit of abstract idea, and that is the example set for the to understand the topic. Okay. Okay. Now to understand the principle of capacitor, consider a conductor, linear conductor, and this is positively charged. Okay, it means if both sides are positively charged. So I have a limit. I have a limit according to its capacity, so that I cannot give it more than that limit of charge. Okay, if suppose the limit is of 10 coulombs, Q equal to 10 coulomb, it means you cannot give more than 10 coulomb of charge to that conductor, otherwise it ionizes the air around it, that is its capacity simply breaks down, its field becomes so high that it ionizes the air around it. That is called breaking point or breaking field. So that's not a part of discussion in deep right now. So I cannot give more than 10 coulomb to this capacitor. So if I want to increase the capacity, we have one trick, and see how significantly that trick simply works. So that is the limit you have got set. You cannot have any other way to increase its charge. But somehow, if you bring another uncharged conductor, okay, again that is isolated. Isolated means there will be no connection, metallic connection between these two. So what happens is this positively charged face induces means it shifts the charges in this metallic body. And this metallic body, if it is metallic, then obviously you have large number of what? Free electrons. So in the electrostatics of the conductors, we read about that when any conductor is put in external electric field, and what happens? The charge gets reshuffled, reshifted, and then come to a certain side and then gets accumulated. The same thing happens. Due to this positively charged side, this side of the conductor gets negatively charged, means all the electrons come in the front side of this face. So where do the positively charged or the positive charge shift? It gets accumulated on the other side of the conductor. Okay, it means the total charge in this conductor is 0, but the charge is getting reshifted, or you can say shuffling themselves according to the electric field set by this. Now see what happens. This the field of this positively charged layer is tried to reduce by the presence of this. If this happens, we know that electric field and potential are directly proportional. Okay, they are directly proportional. So this negatively charged region reduces the field between this region, or in other words, this negatively charged region produces its own negative potential, which tries to reduce the potential created by this region. Okay, now according to definition of capacitance, what is it? V. If V is reduced, then C is increased. It means if we somehow can reduce the potential of that conductor, we can increase its capacity. And capacity means storing capacity of charge. That is, if we somehow can reduce the potential of that conductor, we can store more and more charge on this. So this is done by this negative side charge. It means this negative side is trying to reduce the potential of that particular layer, so that we can provide it more quantity of charge on this. Now its capacity is becoming more than 10 coulomb. It can be 12 or 15 of coulomb. That's got to be a special case. Now we have one more chance, but simultaneously what happens, that is very interesting. Simultaneously the positive layer tries to increase its potential and negative layer tries to decrease its potential. This is being farther away, it is defeated by this negative layer. So finally who prevails? This negative side prevails, and the potential of that conductor is predominantly reduced by this negative layer rather than the increase by this positive layer. Okay, So who dominates? This negative charge layer, and the potential of that conductor gets reduced and capacity increases. Now we have one more trick. You know, there are so many jugards in physics. Now this side is connected to the earth. Earth means ground. The ROUNDD. This is grounded. Okay. Grounded means, now what happens? The electrons from the ground come to this positive side and neutralize this negative side. So we have got one more benefit, that is, this negative side is now demolished. No negative charge resides on the other side of that conductor, and this is left with a negative charge. Remember, it acquires the same negative charge as much positive it has acquired or it has been given. So now this negative layer again tries to reduce the potential now more effectively. If it becomes more effective, then what happened? Potential of that conductor has been again decreased, and if it is lessened again and again, then capacity increases, so we can increase or put more charge on the conductor, because earlier we were giving charge to whom? This conductor only. Now this method has been working more efficiently. This negative charge has reduced its potential so that its capacity increases, and if capacity increases, so what happens? It can store more quantity of charge now. So this is how, by this trick, we can increase the capacity or storing capacity of charge of any conductor this way, that is by placing another grounded conductor near this. So if you place another grounded conductor, what? The conductor should be grounded to the earth, and if it is placed to a charged conductor, then its capacity can be simply increased. And now this arrangement, that is arrangement of one positive and one negative conductor, is called a capacitor. Okay, and so that this system can store a large quantity of charges. Now we shall be discussing about units. Its unit is that of charge and that of volt, and this is known as farad. Okay, the unit of capacitance is farad, and the other units are 1 microfarad, that is 10 to the power minus 6 farad, 1 nanofarad, 10 to the power minus 9 farad, 1 picofarad, that is 10 to the power minus 12 farad. These are the different units of the capacitance of any conductor. Okay, in this video only we are discussing up to the units and its different units. Okay, this is SI unit. We shall discuss about the capacity of some different sort of conductors. These are one isolated spherical conductor, there will be parallel plate capacitor, there will be types of capacitor we shall be discussing in the next video. Okay, till then note this and have a wonderful time ahead. Okay, bye bye.